so you can watch and learn. Okay, today of course we are having chemistry. Every Sundays I usually post on chemistry, and then today we're having an amazing topic before us, which is percentage composition by mass. So how do we calculate percentage composition of each element in the compound? So please pay attention. That's what I'll be explaining in this video this Sunday. So let it be that this Sunday you are learning how to calculate the percentage composition of each element in a compound. Okay, last week I taught on how you can calculate the relative molecular mass, I believe. For those that have been following me, you can calculate. For the students following me here that usually come online each time I'm online like this, to do a video and then teach, you're always active. I believe you can calculate the relative molecular mass. Aside from the relative molecular mass, if you pay attention, I told you that relative molecular mass is actually very important, so I took my time to explain it because we'll be needing it. Like in this topic now, we'll be needing, if you don't know how to calculate relative molecular mass, you actually find this topic difficult to do. Okay, that was why I had to previously do a video on how you can calculate relative molecular mass. So just a brief recap, I told you that relative molecular mass is simply the summation of the relative atomic masses. The relative molecular mass of a compound is simply the summation of the relative atomic masses of the elements, each of the elements that makes up that compound. All right, so we'll still be doing it here. Okay, let us calculate this. They said, what is the percentage composition of each element in the compound? We are expected to calculate the percentage composition of calcium in calcium triazocarbonate 4. This is calcium triazocarbonate 4. So we'll look for the percentage composition of calcium, percentage composition of carbon, percentage composition of oxygen. These are the two elements that makes up calcium triazocarbonate 4. Okay, the same thing, H2SO4. Okay, we'll look for the relative composition of, the percentage composition of hydrogen, sulfur, and oxygen. Remember, if you have questions like this in brackets, they will always give you the relative atomic mass of each of these elements. So they'll tell you calcium. Of course, our calcium is 40, carbon is 12, oxygen is always 16, and hydrogen is 1, sulfur is 32, and oxygen, oxygen is 16. So these are what we need to deal with this question. So having known this, the next thing is to move straight to the calculation. Now, the first element we're having here, the first thing you do, let us solve for A, CaCO3. Now, the first thing you do is to look for the relative molecular mass of this compound, CaCO2. So relative molecular mass of CaCO2 is equal to what? If you have done it before, of course, for those that know how to do it, this is calcium. Remember I said it is the summation of each of the relative atomic masses of each element that makes up this compound. So we would have, what is the relative atomic mass of calcium? From this place, we have it to be 40, plus carbon is 12, oxygen is 16. Because of this theory, we'll say times 3. So if we do everything here, it gives us 12, plus 40 will give us 52. 52 plus 3 will give us 55. Yeah, 55 plus 16. Plus 16, that will give us what now? That will give us 11, right? That one carry 1. This is 5, 6, 7, 71. Sorry, we have not multiplied this. So we have to be 40 plus 12 plus, this time this will give us 48. So if you add everything, 48 plus 2 will give us 60. 60 plus 40 will give us 100. So the relative molecular mass of CaCO3 is 100. Now, that isn't what they said we should find, but we need this in order to find the percentage composition of calcium, carbon, and oxygen. They said of each, you find for this, and this, each of the elements that makes up this compound. Okay, so we have already gotten the RMM of CaCO3. The next thing is to calculate percentage composition of calcium. This is equals to, now look at how you do it. You bring the relative atomic mass of calcium here, right? Calcium is what? 40. So this place, you're having 40 of calcium all over everything. Relative molecular mass of everything, which is what? 100 times what? 100. Per percentage is usually 100%. So these zeros cancel these zeros. So it means calcium, we're having to be what? 40 times 1 will give us what? 40%. So the percentage composition of calcium in this compound is 40%. Just the same way I did that of calcium, that's how you do that of carbon as well. That of carbon, let me clean the board. You see, I want to clean this place. So if you have to find the relative composition of carbon now, remember with the ROMM of this is equals to 100. That of carbon will now be what? Percentage composition of carbon equals to what? What is carbon? Relative molecular mass of carbon is 12. All over, I give it to you here, all over 100. This is the ROMM, which is 100 times what? 100%. I told you where we got this 100%. Talking about we are finding in percentage. That's why we are multiplying by 100%. If you are converting anything to percentage, you have to multiply by 100%. That's what this percentage is here. So we have this because of what now? This 0 cancel this 0. What are we left with? We are left with 12 times 1, which is still 12%. So the percentage composition of carbon in this compound is 12%. You see, the calculation is that simple and it's very easy. Okay, that is all. The next one is oxygen. Percentage composition of oxygen. Percentage composition of oxygen. Oxygen. Remember, we're having three atoms of oxygen in this compound. So it means we're going to be multiplying 16, which is the relative atomic mass of oxygen. 16 here. 16 times 3 all over what? The ROMM 100 times 100%. So everything will now be equal to what? This 0 cancel this 0. This times will give us 48%. So we have done that. So the percentage composition of the elements, which is calcium is from our calculation it is 40%, carbon is 12%, and oxygen is what? Oxygen is 48%. These are our answers. We are done with that question. So the same way you did, you have solved for this A question A. That's how you solve for B. Let's do B together. Let's do B together. So they said H2SO4. Of course, the first thing you do is to find the ROMM of H2SO4, relative molecular mass of H2SO4. ROMM. What is ROMM of H2SO4? Remember, relative atomic mass of hydrogen is 1. So we have to be 1 times this 2 will give us 2, plus sulfur is 32, plus oxygen is 16 times 4. This 4 down here. So if you do everything, it gives us what? This time, this 2 plus this will give us, first of all, 2 plus 32 will give us 34, plus this times will give us 64. 16 times 4, yeah, it's 64, right? Let me confirm. Sorry. 16 times 4, 4 times 6 is 24, right? And 4, carry 2. Yes, it's 64. So after 64, if you add this together, it gives us 78. 78. So ROMM of H2SO4 is 78. I've gotten the ROMM of H2SO4, which is equal to 78. I believe you are following me. 78. Now the next thing, we'll find the percentage composition of hydrogen here. Percentage composition of hydrogen in this compound is equal to what? Hydrogen is relative molecular mass of hydrogen here is relative atomic mass of hydrogen is 1. But we're having 2 atoms of hydrogen. So we'll now have 2 up, that is 2 times 1 up the all over everything. 78 times what? 100%. If you do this, our final answer will be what? Final answer will be 2 here, 1, 2 here, 39. So we're having this to be 100 over 39. 39. If you divide this, before you press your calculator, whatever answer you get, that is the answer. Of course, we'll get it in decimal form. So that will be the answer. Remember, it is in percentage. That is percentage composition of hydrogen. What about the percentage composition of sulfur? Percentage composition of sulfur. We're having sulfur. Percentage composition of sulfur. Sulfur is 32 all over 78 multiplied by what? 100%. So if you do this, if you divide and everything, what are we going to have? This 2 here 16, 2 here we have to be 39. 39. So we're having this to be what can go again? We have to be 16 times 100 divided by 39. If you press your calculator, whatever is your answer in percentage, that is the answer. You see, it's very simple now. If you press your calculator, whatever you have as your answer, that is the answer. Let me just press my calculator here. So I have it to be 16 times 100, 16 times 100 divided by 39 equals to. So I have 41%. That is the percentage composition of sulfur. So what about the percentage composition of oxygen? Please, you do that of oxygen and drop your answer at the comment section, okay? That of oxygen, do it for me and drop your answer at the comment section. Look at it, H2SO4 for oxygen. Percentage composition of oxygen. This will now be what? 4 times. Just do it. Let me not do it for you. Do it as a proof that you understand what I'm saying. Put your answer at the comment section. Now, that is how you calculate percentage composition of any elements in any compound. There are some questions whereby they will tell you that they will be specific, like calculate the percentage composition of sulfur in H2SO4. This one, they are specific that it is sulfur we want you to calculate for. So that means you don't have to calculate for everything. All you need to do in this case is to find the RMM of H2SO4. Then you now, from the RMM, you now get the percentage composition of sulfur by bringing out only sulfur. That is, it will now be 32 all over whatever is the RMM of H2SO4 times 100% for sulfur specifically. Okay, but if they say everything, that means you have to do for hydrogen, sulfur, and oxygen. So do that of oxygen. I've already done that of hydrogen and sulfur. You do that of oxygen. Oxygen, and put your answer at the comment section. I believe you're learning something tonight. So I want to quickly teach you something in chemistry again. That's for RMM. Please take note of this formula. How to calculate I want to give you a relationship in chemistry. Relative molecular mass, relationship between number of mole, relative molecular mass, and the reacting mass. Okay, there is a formula that connects them. Please take notes. Number of mole is equals to reacting mass over molar mass. Now, take note, molar mass, if I say relative molecular mass and molar mass, they are the same. The difference is that while this one is in gram, molar mass is in gram, relative molecular mass does not have any units, okay? But that is, molar mass is simply relative molecular mass expressed in gram. So do not be confused, they are still the same thing. Are we on the same page now? Yeah, they are still the same thing. So if you're asked to calculate number of mole, this is the relationship. Reacting mass over what? Molar mass. Are you getting it now? So a situation where they said you should calculate the number of moles. Calculate the number of moles in 12 gram of oxygen. Number of moles in 12 gram of oxygen. Remember, oxygen is a diatomic molecule. In other words, if I say a diatomic molecule, it means it exists as two molecular form. Okay, it has two atoms. Okay, oxygen does not exist as a monoatomic molecule. Okay, it exists as what? A diatomic molecule. So what do I mean? We're having oxygen like this, something like this, oxygen. Remember, the relative molecular mass of oxygen is 16. So if you have to solve this question now, look at what you do here. Solution. Please pay attention. Of course, I will always give you work to do. For those that submitted their previous work to me, I have marked it and then I always make it. That's why it's very, very important that you do the assignments and submit. I will show you your error. You tell me the areas you don't understand. Some persons usually submit and then they will tell me, oh, this particular question, I don't understand this area. Then I will, explain it to them. Okay. So make sure you pay attention, and whatever assignment I give to you, make sure you attend to it and you submit to me personally. You know how we usually do. You don't know how to, if you don't know how to go about submitting your work to me, please, or how to, you don't usually get the assignment, just drop it at the comment section. I don't usually get the assignment. I don't know how to submit to you. Just drop it. I will send you my number and then you can always reach me anytime. So calculate the number of moles in 12 gram of oxygen. Now look at it here. Number of moles. You look at the formula. Number of moles equal to reacting mass over molar mass. Reacting mass is the given mass from the question, the mass given to you in the question, which is 12 gram. So we have gotten our reacting mass. What about molar mass? Molar mass of oxygen molecule. Oxygen, remember I told you that it exists as a diatomic molecule. So if I'm to find the molar mass to now be, that is, I'm finding the molar mass of O2, a diatomic molecule. So it will now be what? 16 molar mass of O2 is equals to what? That is 16 times these 2. This 16 is gotten from the relative atomic mass of oxygen times 2, which is equals to what? If you multiply everything, it gives us 32. Yeah. So we have gotten our reacting mass, we have gotten our molar mass. The question says to find the number of moles. Just apply this formula. The number of mole equals to reacting mass. Reacting mass is what? 12 gram over molar mass 32. If you do this, it gives us what? 2 here 6, 2 here 16, 2 here 3, 2 here 8. 8 moles. That is the answer. 3 over 8 moles is the answer. If you change it to decimal, it will give you 0.375 moles. 0.375 moles. So that is how you calculate number of moles. Okay. Now you do this one for me. Calculate the number of moles of in 20 gram of CO2 molecule. The number of moles in 20 grams of CO2 molecules. On this number of moles, all you need to do is to the reacting mass is given from the question. The molar mass is what I told you how to get molar mass. You only need to find the relative molecular mass. The relative molecular mass expressed in gram is simply molar mass. So everything is complete. You know what to do. Get your answer and put it at the comment section. Okay? I believe you have learned something. If you know you have learned something, just drop it at the comment section that I have learned something.